Hey, welcome to day 9, parallel line proofs in honors geometry. Just reviewing a little bit of angle relationships before we get into actual proofs with these angle relationships. So let's see. We have in this picture, use the picture, give an example of each relationship. So go through and just try to identify one set of vertical angles. So a vertical angle could be like angle 1 and angle 4. Those would be vertical angles. A linear pair makes a straight line. So any pair that's next to each other on a straight line, so I could say angle 3, well, that's not a very good color, it's hard to see. Let's do angle 3 and angle 4. They're next to each other and they make a straight line. You can do vertical or you can do horizontal. Consecutive interior. Remember, interior means they are going to be between the two lines, and the word consecutive means right next to each other. So angle 4 and angle 6 are considered consecutive interior. Let's look at alternate exterior. Exterior are going to be outside of these lines. So alternate exterior means on the outside and on opposite sides. So like angle 1 and angle 8 would be alternate exterior. Or you could say angle 2 and angle 7. Alternate interior, same idea. This time they're inside, so between the lines, but on opposite sides. So like angle 3 and angle 6. Or you could say 4 and 5. Corresponding are the unique ones when they are in the same position. Like one is inside, one's interior, one's exterior, and they have to be on the same side of the line. So angle 1 and angle 5 are considered corresponding, or 2 and 6, or 3 and 7, 4 and 8. They're all in the same location. Okay, so let's now go down here, and we're going to go to a proof. On this proof, we always start off all proofs with our givens. So I'm going to write number 1. First off, in the picture, we're going to add a A and a B to this picture because it says given. Oops, don't write the word given there. That's what it says. We're going to say number 1, A is parallel to B. Those are those lines. And the measure of angle 4 is equal to 15x minus 5. And the measure of angle 3 equals 65 degrees. On these, typically what you want to do is you want to state the angle relationship, and then you're going to tell me like what's true about that angle relationship. Are those two things equal or are they supplementary? So, looking at angle 4 and angle 3 in my picture. Those two angles are called consecutive interior angles. So we would write on this step 2, angle 4, or angle 3 and angle 4 are supplementary. And the reason we know that is because those are consecutive interior angles. And they call it a theorem, so I'll just write that over here. The theorem says that consecutive interior angles are supplementary if the lines are parallel, and we know the lines are parallel. So what does it mean to be supplementary? That means the measure of angle 3 plus the measure of angle 4 should equal 180 degrees. That's called definition of supplementary angles. Okay, So now we're going to do substitution and put in the information that they gave us. Angle 3 was 65 degrees, plus angle 4 is 15x minus 5 equals 180. That's substitution. Now I'm going to go ahead and combine like terms and get 15x plus 60 equals 180. You can call that just simplify or combine like terms. Now we're going to subtract the 60 to the other side. That would be subtraction. When it crosses the equal sign, we call it a property of equality because it went across the equal sign. So subtraction, property of equality. And then the last step, when you divide both sides by 15, you should get x equals 8. Division, property of equality. We divide across the equal sign. So one thing you always want to double check is your proof your last statement in your proof? Another thing double check, is your given statement the first thing in your proof? So given is always at the beginning. What you're trying to prove is always at the end. So let's try another one. This is still in Algebra 1. We're going to write our givens down. In this picture, we'll call this line A again and this line B. So we can say A is parallel to B. If these lines aren't parallel, then they're not congruent or supplementary angles. So that's why it's important that we have that step. I'm just copying this directly from the given. Okay, so I'm going to look in the picture and see what we have. We have angle 5 and angle 1. So angle 5 and angle 1. We have to decide what kind of relationship is that. Those are considered alternate exterior. And so then what do we know about alternate exterior angles? We know that the measure of angle 1 should equal the measure of angle 5. And the reason is alternate exterior angle theorem. Okay, so now we're going to do substitution and plug in the numbers that are given. So we have angle 1 is 5x plus 2. Angle 5 is 7x minus 18. Okay, you can decide how you want to solve, if you want to move the x's to the left or to the right. In this case, this one really doesn't matter. I typically move the x's to the left just because sometimes that's all you're doing is trying to prove what x equals. So I'm going to subtract 7x this way and get negative 2x. Then I could have done this in one step because I'm going to end up subtracting the 2 to the other side to get negative 20. Since they were both subtraction, technically I could have done that in one step. Then I would divide. Property of equality. I meant division across the equal sign. Alright, so now if we look back up here though, under my prove, this wants us to prove measure of angle 1 is 52. Well, I just have x, so I still have to figure out what is the measure of angle 1. Oops, let's erase that. So on step 7, I'm going to plug that in. Angle 1 would be 5 times 10 plus 2. Call that substitution. And so, let's see, make sure my math is right here. That would be 50 plus 2 is 52. We call that simplifying. So, just to show, at the end we have prove measure of angle 1 is 52, and look at my last step. I have the measure of angle 1 is 52. So, our work matches up. Alright, let's look at this one. This one is just words. There is no algebra to do to it, so there's nothing past like substitution here. We have our given. Again, I'm going to call this line A and this line B. So A is parallel to B. We want to prove a relationship between 1 and 6. Okay, so we don't have necessarily a relationship just in our choices. So we want you to try and prove that those two are supplementary. So you can either start at the 1 and try and get to the 6, or start at the 6 and try to get to the 1. So I'm going to start, let's say with 1 and 8. I don't know, I'm just going to pick one. Why could you know that like angle 1 and angle 8 are supplementary? Well, in this picture, one and 8 make a straight line. They connect to make a line. So here, I'm going to say 1 and 8 are supplementary because that's called linear paired. There's also something on that handout that I'd given last class that sometimes they call it the supplement theorem. But if you tell me you chose 1 and 8 because they made a straight line, they're a linear pair, I am fine with that. If you can identify the angle relationship. So now, could you say that there's now a relationship between the 8 and the 6? So we're trying to get the 1 and 6. So the 8 and 6 have a relationship. We would say those are congruent. Oops. Angle 1 is congruent to, oh, wrong one. We're looking at the other ones. Let's say, we'll just call the measure. The measure of angle 6 is equal to the measure of angle 8. Why do we know those two are equal? Because those two are called corresponding angles. Guess we could use the angle symbol, corresponding angle theorem. Okay, so now, if you look at what we're trying to prove here, prove 1 and 6 are supplementary. We said 1 and 8 are supplementary, and 6 and 8 are equal. So on this last line now, I can say angle 1 and angle 6 are supplementary. And we know that by substitution. So in this problem right here, I said 1 and 8 are supplementary, and 6 equals 8. So where the 8 was, I substituted in the 6. So that was by substitution. Now 1 and 6 are supplementary. With that being said, there's lots of correct ways to do this one. There's no one way. For instance, we know the original one they're looking at is 1 and 6. So you could show the relationship between 1 to 2, saying they're linear. And then you could say 2 and 6 are alternate exterior. That's another way you could do this one. Another way to do this one, you could say 1 and 5 are alternate exterior. And then you could say 5 and 6 are a linear pair. So lots and lots of choices on how you want to get by substitution at the end. 1 and 6 are supplementary. It's just a two-step kind of problem, how we can